Hi, this is Mrs. Slater, and today we're going to talk about probability and know how to solve different types of problems. So let's first talk about the definition of probability, which is total winners over total possibilities. And probability can only be between two numbers, which are 0 and 1. Now, you should also put a little equal sign underneath there, because it could be, you could have a probability of 0 and you could have a probability of 1, which would mean 100% of the events would be happening. Okay, there's two types of probability that we're going to be discussing, and that is discrete versus geometric. Discrete are probabilities that are countable. And geometric are not countable. And you'll most likely see geometric probabilities when we are measuring length or area or angles of rotation. Okay? And I think I spelled that right. Maybe there's an E in there. I don't know. Okay, anyway, let's go on to some examples. The first one has, yeah, as you can see, 6 angles in the box here. So this is an example of discrete probability because we can actually count these. What's the probability of an acute angle? Well, as you can see, there is one here and there is another one right here. So because there are 2 winners out of the 6 total possibilities, the probability of getting an acute angle out of this bunch is going to be 1/3. Okay, go ahead and try that for the next 4 problems. Push pause and see if you can do it, and then check your answers. Okay, now that you're back, you should have got an answer of 1/2 because there were 3 different obtuse angles out of 6. You should have had 1 out of 6 for right angle. Straight angle, there weren't any, so this is one of those 0 probability. And what was the probability of getting an angle out of this bunch? Of course, 100%. So the answer is 1. Okay, so let's go to the next example. One way you can do this is to think of it as like a bag of marbles. You're taking out an angle, and then you're not replacing it, and then you're going back into the bag and grabbing another angle. So if you think of it that way, maybe that will help. Anyway, so you're trying to figure out acute first. So what's the probability of getting acute? Well, we found that before was 1/3. Okay, now that acute angle is not in the mix, so we're going to have to get another acute angle based off of what is left over. So there's only 5 angles in there, and there is 1 acute angle left out of the 5. So we're going to multiply 1/3 by 1/5 to get the answer of 1/15. That's going to give you the probability of picking both acute angles. Okay, the next one is the same type of thing. So I want you to go ahead and push pause, see if you can figure it out, and then check your answers. So right angle would be 1/6. An obtuse angle is 3/5 for an answer of 3/30. And we always want to reduce our fractions to the lowest terms. And then the last one, you have 3/6 for the obtuse, 2/5, and then after canceling, you end up getting 1/5 for the probability of getting an obtuse, replacing, or not replacing, and then grabbing an acute. Okay, let's go on to the next part, which is on the next page. Another way you can do these type of problems is by making a list. So you might be more comfortable with that. This is be for anything when you're picking items or angles that are not replaced. So what I have done in blue here is labeled every single angle, A through F. Okay, and if you want to picture drawing 2 at once, then I made a list out of those. So we have A, B, AC, and so on all the way to EF. So it gives us a total of 15 different possibilities. Okay, so then if you look at all the examples that have an acute angle, and I'm referring to this one, by the way, Okay, this one is acute here, and this one's acute. So the only possibility in my list would be A and C. A and C does not happen anywhere else, so that means that it'd be 1 out of 15 possibilities to get both acute angles. So that's just another way to do it. You may like that method a little better. Okay, now let's move on. Okay, so now we are talking about if two angles are selected at random and then it is replaced. So it's like starting from scratch every single time. Still multiplying, so if it's both acute, the first chances to get an acute is 1/3. Put that back in the bag, and then 1/3 again would be the next one for a total of 1/9. So that would be the probability if the angle is replaced in the box here. Okay, let's go on. Okay, so this is an example of a geometric probability where you're dealing with area and the space that is for each. Like the triangle would be an area and then the rectangle itself would be an area. So if the roach is stuck in the box at 10 by 15 inches, that's going to be the total possibility, because that would be the area of the rectangle. So that would be 150. Okay, and then also the triangle is 1/2 base, which is 6, and you probably can't read it very well in your paper, so I wrote it up here where the height is 5 inches, or 5 inches, yes. Okay, and then after cross multiplying, we have 3, we have 15, and then reduce, we get 1/10. So does that answer the question? What is the probability it will not stop in the red region? No. So this is the probability that would be in the red region. So what would be left is 9 out of 10 is the probability that it's not going to be in the red. All right, very good. And look at that happy roach. Very excited you got the answer correct. Okay, so let's go ahead and go on to the next one, also geometric probability. We have an arrow that is going to be shot and trying to hit the purple. I think I called it purple because it used to look purple. Anyway, so we have a arrow. What's the probability? Okay, I want you to push pause and try it. Okay, so of the rectangle, we know it's 10 by 2. And then the bottom is going to be total area, so that would be the circle, which is pi r squared. And then after reducing, we get 20 over 196 pi, and reducing one last time, pi over 49 pi. So that's going to be the exact answer. And then the rounded answer to 2 decimal places would be 0.03. And if you're putting as a percent, it'd be 3.25%. And the last example is geometric probability as well. It's about length, so you have to think of it as what is probability that this random Q would be 2 points away from S. Okay, so the length from there is 2 units, and the length of the whole entire segment is 9. So the answer is going to be 2/9. And the next one, 2 units away from M, 1, 2. And since we can go either way, let me get rid of the rest. We can go either way. That gives us a total of 4 and then 9. So the answer is 4/9. And then the last one is 3 units away from B. So 1, 2, 3. So that's a distance of 3. And then again, out of 9. And we always want to reduce our fractions. Okay, so that's it for the day.